the Google Gemini model, specifically Gemini on Vertex AI. And so, who am I? Some of you, I guess, already know who I am, which is still kind of a weird concept to me. But so, my name is Holt Skinner. I am a developer advocate for Google Cloud, or Google Cloud AI specifically. I live in very sunny Austin, Texas. It's very hot right now. I'm actually going to be escaping to Europe starting next week to get away from the summer heat. So, I'm going to be going there for about a month and a half, specifically Switzerland. If anyone here is in Zurich, awesome. I'm excited to come visit your place. And so what do I do as a job? I write a lot of code for people to use, specifically other engineers at other companies. So I make sample code, I make notebooks, I make demos, all that kind of stuff that's intended to help people learn how to use Google Cloud products. So I help software engineers a lot. I make a lot of technical educational content, like videos, blog posts, all that kind of stuff. And I also work to make our products developer friendly. And, I do things with building online communities, and I talk at conferences. Like I just spoke a couple of weeks ago at the AI Engineer World's Fair. If any of you guys heard about that, it was in San Francisco. I also talk a lot at Google Cloud Next and I/O and those kinds of things. So let's get a little intro of what I'm thinking about here, about this whole AI thing. So a few months ago, I found this particular post on Reddit. And so it says, I want AI to do my laundry and dishes so that I can do art and writing, not for AI to do my art and writing so I can do my laundry and dishes. So as someone who works with AI on a day-to-day basis, this is exactly what I want this kind of technology to go towards. I mean, sure, AI has come a long way in a very short amount of time, and we've seen some of the incredible content that can be generated with this. Things like photorealistic images, detailed summaries in just a few seconds. It can write complex code. However, I still think that AI will never replace humans for creative tasks. So, for example, I thought this was hilarious here. So I think, obviously, this real image winning an AI photo competition proves that humans are indispensable in the world of art. And that being said, my philosophy is that AI is a highly useful tool that can be used to assist in the creative process, improve efficiency, and automate things that are tedious to do. But I don't want it to be replacing people for any kind of thing that is uniquely human in nature. So in other words, have AI do the stuff that we don't want to so that we can spend more time on the things that we enjoy, right? So, for example, I'm all about automating things that I don't want to do. For example, I have a robot vacuum cleaner for each level of my house. I recently got a robot lawnmower, which these things are great. So I don't have to spend hours on outside maintenance. I have smart light switches, connect to a Google Home, smart thermostats. So all that stuff is automated. And of course, I use generative AI tools like the Gemini chat app to help me get parts of my work done faster. I'm personally not a fan of using it for creativity, except maybe reducing writer's block, but I like to use it to simplify tasks. And so what I'm going to talk a little about here is just how Google has been working in this space and how we can empower developers out there to take advantage of these models. So Google has been a pioneer in AI for a very long time. That's one of the main reasons that I wanted to work here personally. Google has been kind of one of the leading researchers and developers in this kind of technology for quite a while, actually. You may not be familiar with this, but Google actually worked with the University of Toronto early on, I believe in 2016, 2017, to invent the transformer model, which is what all large language models and most generative AI is kind of based on at this point. So it's been around for kind of a while, and it's fascinating because this technology has been available for, it's been around for about, I guess, 8 or so years at this point, which is kind of wild to think about, but nowadays, we're seeing this huge resurgence in it because, well, OpenAI released a free version for everybody, and then the general public kind of realized, oh, this is something that could actually be very useful for us, and so it kind of kicked everyone into gear, and we're kind of saying, okay, we need to be releasing everything we have right now to figure out kind of what's going on, figure out what we can do with it. And so the kind of result of this on the Google side is the Gemini model, which is the result of more than 3,000 scientists and researchers across DeepMind and Google Research. And they've published a whole bunch of papers on this things too. And so Gemini is a multimodal model, right? So why does this kind of stuff matter? So the idea of this is that we improve the understanding, understanding of the content that's actually being presented, and it gives us more accurate representations overall. Think about how like a baby or a child learns. They don't exactly read about how to talk. They just kind of observe and learn from hearing other people, seeing lips move, and then seeing maybe food brought to them as a result, or other things by feeling their own lips move. overall. And as we move on to, say, like agentic or agents types of applications for AI, models will need to better understand their environment and make decisions based on that context. So multimodal information better mimics what the human brain does, right? And delivers better results in reasoning and generation, which is why it's really important that Gemini works multimodally. So it is a generative AI. Gemini is a generative AI model, but it works multimodal across like all different types of information. And so we've kind of looked at a little bit about the evolution of AI over the years. So we first kind of seen the first kind of big wave of AI was from about 10, 15 years ago with predictive AI. This is your regression and classification, forecasting, sentiment analysis, this kind of classic AI, which we've started calling predictive AI overall. And then we've kind of had a second wave of sorts, which is from about 2 years ago, which is the first generative AI wave, which is all about language models, text, image code generation, all that kind of stuff, summarization. And then now we've kind of moved on to this next layer of multimodal AI, which works with various inputs, including text, images, audio, video, documents, and is able to kind of use reasoning across all of them to handle more complex situations. And so this is what we mean by the era of Gemini, which we mean the era of multimodal generative AI. And so Gemini is natively multimodal, so it works across all these types of things. It utilizes different types of sophisticated reasoning. So it can analyze vast amounts of complex information and extract insights at high speeds, making it pretty valuable in fields like science, law, finance, pretty much any industry that wrestles with that challenge. And there's also a large ecosystem of tools, integrations, and other supporting pieces around Gemini that enable it to be even more powerful for specific use cases. So let's look at kind of what has been recently announced on the Gemini side and what's most useful to developers out there. So we have Gemini on Vertex AI. So Vertex AI is part of Google Cloud. And if you're not familiar with Google Cloud, I mean, I hate having to say this, but one of the best ways for people to think about it is it's Google's Amazon AWS. So it's basically a platform for you to deploy applications, and there's all sorts of different products out there that do all sorts of different things. Everything from like VMs, Kubernetes engine, data analytics, and of course AI. And so these are the kinds of features you can see with Gemini specifically deployed on Vertex AI. So we have two main the kind of latest models. There are two different flavors of it you can look at right now. We have Gemini 1.5 Flash and Gemini 1.5 Pro. 1.5 is the current version. We also, of course, have 1.0, which is the older one, but most use cases nowadays are using 1.5 at this point. Flash is kind of the fastest and super cost-efficient version of this. Gemini 1.5 Pro has a higher level or more advanced reasoning. It has a little higher quality bar. It's just a little bit, higher latency. So most use cases, you kind of want to try out Gemini 1.5 Flash first for anything because it still has the long context window that both Gemini models are known for, but it's much lower latency and it also is a little bit cheaper. So let's actually talk a little about this context window. One of the main features of Gemini 1.5 is a 1 million token context window. And so what that means is that you can put in a lot of data into this model and get kind of get whatever output you want out of that. And so there's different kinds of ways that you can utilize this here. For example, it's useful for like long form video and audio analysis. You can put in about an hour's worth of video along with the audio. You can put in large documents and get summarizations or get entity extraction from it. You can also do a lot of well, in this case, it says many shot in context learning. So instead of just few shot, you can add in a lot more examples if you need to for those kinds of things. And of course, the performance has been pretty good overall. So this is from artificialanalysis.ai from just, I think, last week, it looks like. And so Gemini 1.5 Flash seems to be it has one of the highest output speeds out there. And it offers a pretty good balance overall of quality versus the output speed if you need that. And then one of the other main features that on Vertex AI for this is grounding, which in generative AI, grounding is the ability to connect model output to verifiable source of information. So if you provide models with access to specific data sources, then grounding basically tethers their output to this data and then reduces the chances of just hallucinating or inventing content, right? And this is important in situations where accuracy and reliability are paramount. So, reduces hallucinations overall. It gives you specific information. It also can, if you use grounding with your own data, you can also provide generative AI models with information that they wouldn't have had otherwise in their training data, right? So if you want to connect this to like some proprietary information or like employee onboarding information or secret information for your company or something like that, you can connect that in there using this. And then Gemini will be able to actually answer questions for it. And there's also different ways that you can customize the output of this. For example, control generation is actually very cool. So you can say, type into a language model and say, oh, please respond in the form of JSON because I want to put this into an API somewhere. But, it usually will work that way, but there's not really a guarantee of that. There's not a way to kind of filter that out. You have to kind of do some parsing afterwards to handle that. Control generation allows you to provide a specific format. You just say, like, I want this MIME type to return in this, say, JSON. And you can also define a specific schema, and it forces the model to respond in that format, which is really nice. There's also things like provisioned throughput, which is designed for high scalability of this, and context caching is really nice for anything with this long context. So, for example, what you can do with context caching is that if you have like a whole code base you wanted to analyze and you want to do stuff with it over and over again, or you have a lot of documents you want to analyze, or a video that you want to process, do multiple things for, you can actually cache that. And what that ends up doing is that it saves you a lot of time on latency. It also is a lot cheaper than processing it over and over again. It allows you to save it in Vertex AI, so you don't have to send it up to the model every single time. So it's really nice. So let's zoom out a little bit from Gemini and let's look at the whole Google Cloud AI ecosystem that's around it, which is all Vertex AI. So if you've watched any of the keynotes or stuff for Google Cloud Next or I/O, you've probably seen some of things like this before. All this is to say is that Vertex AI has a lot of different features for the entire model lifecycle for anything AI related. So you have things like pre-built solutions that are designed for more like out-of-the-box use cases like contact centers and healthcare and things for retail and all that sort of stuff. You also, of course, have things like Gemini for Google Cloud or Gemini for Google Workspace or Gemini Code Assist. That kind of stuff is designed for kind of everyday automation. Things like in docs, you could do help me write, which lets you just say, I want to write a doc about such and such thing, and then it will generate, a template for you or something along those lines. And there's also features for like code completion and help or there's like a chat thing in the actual Google Cloud Console that, if you ask, say, like, oh, how many VMs do I have running right now? Or even something more complicated than that. It's able to answer that based on your specific environment. And then there's a few other layers below that as well. There's like the Vertex AI Agent Builder, which is just kind of a fancy name for all the stuff that we're using, all the stuff we have that is designed for taking generative AI and building actually useful applications for it. We say the word agent a lot, and all an agent is just software that does work on behalf of the user, right? So this can be things like chatbots, it can be automation tools, it can be orchestration, all that kind of stuff. We're considering that agent builder. Then we also have Model Garden, which is just a way that you can access, I guess, 150 plus enterprise-ready models from Google partners, open source. So you can access, of course, Gemini models on there. You can also access our other foundation models, which are like the older Palm 2 model, Imagine, Chirp, which is a speech-to-text model, Cody, which is specifically for code completion and code generation, and then embeddings models. And then there's all sorts of other ones that are, some are Google specific, some are from like the open source community, like we have Anthropic Claude, Llama, and there's also integration with Hugging Face. We have Google's open source generative model, Gemma. So there's a lot of different ways to kind of get to that. Then you also have Imagine 3, which is like the latest version of our image generation model. It's very cool. And I think Imagine 3 is in public preview or is in preview on Vertex AI now, but it's going to be more public later. And there's also features for MLOps. I'm not super experienced in this area, to be honest, so we're going to kind of gloss over that. So I've talked enough here. Let's actually get started and do some cool stuff with this. So one of the easiest ways to get started using Gemini is with Vertex AI Studio, which is just in the Google Cloud Console. and it's just a tool to help you rapidly prototype and test generative AI models. So you can test out prompts, you can design your own prompts, you can customize the models to handle tasks for your specific needs. And this also might be a good place to stop for any questions we have here. And I lost some. I lost the messages here. There was one in here. I don't know if they deleted it, but I remember seeing a thing in here in the chat that said, "What's the difference between grounding and RAG?" Grounding is basically it's just another. It is kind of another term for RAG. There are some different subtleties in how that works, but grounding is kind of one of the main features. Grounding is the name of the feature in Vertex AI that is basically implementing RAG on the back end. And it can be done with Google search or with Vertex AI search, which is another product. Okay, but let's look into Vertex AI Studio here, and we'll just show a couple of examples. So when you open up the Cloud Console here, you have lots of options here. So you can go into Model Garden, see all those different models available. You can also build like custom training pipelines. You have Jupyter notebooks that you can build your own Jupyter notebooks and here. And then these are all the different types of models you can try out in Vertex AI Studio. I'm in the prompt gallery right here, which I think is pretty neat because you can actually go in here and see a bunch of prompts that are written specifically for the Gemini model. So let's see if there's any here that are kind of neat. Here we go. Here's something that describes video content. And so whenever I clicked on that, it automatically pulls in a sample video to look at. Let me also make sure I'm presenting correctly. I am. And in this case, the prompt is pretty simple. Just write a detailed description for the video. You can also go in here and edit system instructions, which is just telling the model how it should respond or give it context, anything here. I'll start this and I'll kind of go over some of the pieces on here. You can insert media if you want to add in stuff like images, documents, videos, audio. You can select the model that you want on here. There's actually a few different models available in here, like there's Gemini 1.5 Flash, Gemini 1.5 Pro, experimental, which is just kind of whatever the latest version of Gemini that we currently have out there is. And you can adjust things like the temperature, the output tokens, safety settings, and other things like the top P. And this is where you can enable grounding as well. So here we go. This thing was actually pretty fast. I'm kind of impressed by it. So it gives a nice summary of that. If I could also put respond in bullet points or something along those lines if I really wanted to. And so you can actually go into this here and you can try all these across different types of media. So you could also do this with documents, for example, here. Like if I wanted to say, here we go. Oops. So here is a sample document that looks just like a fake earnings statement here. And I just say okay, here we go. This is like a kind of an example of system instructions here that describe kind of what we want the model to do. And then we just say, okay, we want you to respond in this specific format. And this is not using that control generation stuff that doesn't work currently in the UI, but it's an example of how you could get this to respond in some kind of structured data. And so it extracts kind of all the information from that document, from the PDF file that we added in. Okay, let's go back for a second here. Now, of course, this can also be used through the Vertex AI API for Gemini, which is pretty straightforward to get started with. And I'm going to actually show you a notebook in a little bit that just shows you how to do this. So if you just want to do like a base request and stuff, it just takes a few lines of code to get started. What you have to do first is create a project, and then you can go in there and enable the APIs and set up all of that. The main thing I want to kind of highlight here is this generative AI Generative AI on Google Cloud GitHub repository. This is something that my team and I maintain. So let's actually go and check it out a little bit here. This is a GitHub repository that has all sorts of different examples for how to use generative AI with Google Cloud. You can see, of course, we have a Gemini folder here with all sorts of examples. We have a lot. Getting started right here has a lot of these introductory notebooks for this, which is what I'm going to show in just a minute here. There's also other features in here like context caching, which I talked about a little earlier, control generation. There's an example notebook in there. Evaluation, if you're interested in that. We have lots and lots of examples for how to do model evaluation. There's also some cool features in here like function calling, which allows you to kind of control the Gemini output to make it basically, let's see, it allows you to control the Gemini output so that you can use it to call functions. So you basically pass in a open API specification for whatever function that you want it to call, and then Gemini will respond in a format. So it'll extract like parameters and all of that kind of stuff and find which function name you need, which we can look at that in a little bit actually. Reasoning engine takes us a step further where you can just pass in a Python function and Gemini will figure out, okay, these are the parameters you need, and it also will call it for you. And you can deploy those on things like cloud, on serverless architectures like Cloud Run. Okay, we've looked at this repository here. So this is what we're going to kind of go through here. We're going to go through this sort of 101 example. If you are more advanced, you are welcome to go ahead and go into the repository and try out some other things in here. But for anyone here who is kind of just getting started with this, I'm going to kind of go through this just to kind of see some examples. So you can go to this QR code, which has this, goes directly to this notebook in the GitHub repository. You can also go to this short link right here. Now, whenever you actually click on this link, it will open up in GitHub. And then you have a bunch of links on here which allow you to open it in Colab, which is just a it's a free Jupyter Notebooks tool made by Google that you can try out. There's also Colab Enterprise, which is part of Google Cloud, which is just some more advanced features for Colab. Another, there's Vertex AI Workbench, which is just another managed system for notebooks. But if you click on any of these, it'll open up the notebook in a system you can run it in. And I already have this open in Colab, and I'm going to kind of show you how this thing works. So I'm already connected to a runtime, which allows me to actually run these commands and everything on here. And so we have some just overview information about the models in the Gemini family. And with this tutorial, it's going to be using the Vertex AI SDK. We're going to do some audio analysis. We're going to do some video analysis, extract information from PDFs, and process images, video, audio, text simultaneously. Very cool. So the first thing you're going to need to do is install the Vertex AI SDK, which I think I already have already, but just for kicks, we're going to do it. You might see this little warning here if you're running in Colab. It's fine. Just let it run anyway. It'll take a few seconds here. And then once this is done, you're going to have to actually restart the runtime. This is just a thing that you have to do for Jupyter Notebooks sometimes when you install new libraries. So this cell right here will automatically restart it for you. And it says it crashes, but that's fine. It'll restart. And then you have to also authenticate, which allows you to connect your Google credentials into this notebook, and it'll allow you to authenticate to Google Cloud as well. And it popped up a little extra thing on my screen. You just couldn't see it. There we go. And now I'm going to enter in my project ID. If you haven't already created a project before, you can actually click on one of these links in here, and it will show you how to do that and also how to enable the API. So these are pretty straightforward guides that show you how to kind of get started with that. I'm going to take my own project ID, stick it in, and then initialize the Vertex AI API, or the SDK, sorry. There we go. We are initialized. We're going to import some libraries just to get all the classes and things we need ready. We're going to create our model instance here. We're going to use Gemini 1.5 Flash. Okay, and here we have some kind of basic usage with this. We have our example model here, which we pass in the model ID, and then we can also pass in a system instruction here to give the model some context of what we want to do. You can set parameters in the generation config here, like the temperature, which is, some people like to say it's the creativity of it. The higher the temperature, the more creative the responses can be. So if, in general, if you want like 100% accuracy with information you're providing, you'll be closer to 0. If you want something that's more out of the box thinking, then you can turn it up to, I think, up to 2. Top P, top K, these are just some general things that determine like how the tokens that are output are selected. Candidate count, this is how many options it provides. I think currently you can only do 1. Then max output tokens is how long the output string should be. And then safety settings, there's built-in stuff for responsible AI in Gemini. This basically just prevents bad content from coming out or going in. So if you have like harassment, hate speech, sexually explicit, or dangerous content, you can change these thresholds to be more sensitive or less sensitive. There is a way you can completely disable these if you want, but you need special permission and allow listing for that. And then we have our prompt that we're going to run in here, which in this case, we're going to be doing text from English to French. And then so you can count the tokens before you send them in if you want. This can help you determine like how much it's going to cost to run some of these queries. And then here's where we actually make the call to Gemini. We do whatever model.generate content. We pass in the prompts that we gave it along with any other data we want to do, the generation config and the safety settings. And then this is where we are going to output all of the data here. So there we go. We're going to run it. Nice. So in this case, this short little prompt here is only 14 tokens, and we can also see the characters in here. And here we go. We have our answer, which is, let's see, I'm not going to try and butcher French. I'm sorry. We can also see and hear the actual usage metadata, which is how much information was actually used, or how many tokens were actually used in there, why it finished, which in this case just meant it stopped. And then we can also see the information about the safety settings. So for example, if your model or if your response kind of gets blocked for some reason, it'll show up in here saying like the probability is high that you put in hate speech or something like that. And it'll tell you the probability score of that. So let's look at a couple of examples for audio understanding as well. This one is just a little, I think, a review from one of the Pixel phones. I think if we run this, actually, it'll bring up a little thing that we can actually play the audio if we want. I don't know how well that'll work over Zoom, but we'll see. It's a 10-minute audio clip.
Your devices are getting better over time. And so
yeah, it's a little
of deciding what's coming in a feature.
Sounds like a podcast of some kind. Okay, so here's an example with summarization. We just say, please provide a summary for the audio, provide chapter titles, make it a little organized and fancy. And here we go. Do not make up any information that's not part of the audio, and do not be verbose. This is an example where you might want to turn the temperature down a little bit, but we don't have that set on here. So what we're going to do for any of this multimodal input, we're going to say part from URI. We're going to pass in a Google Cloud Storage URI, which is just a way of storing files on Google Cloud. Pass in the MIME type of it. And then we can see how it responds. And so this is 10 minutes of audio, and there we go. It's it's very, very quick. I'm kind of impressed by it. So it gives us kind of the summary of this here, made by Google Podcast Pixel feature drops. It gives us chapters. It basically just gives us kind of the summary of what's going on in there. Being very concise and short. Yes, it is. Excellent. And so we can also do this kind of in a more verbose fashion, like transcribing this interview. We can actually say timecode, speaker, and caption. And we can say specifically how we want to identify the speakers. And this one is also an example here of showing streaming responses. You can actually pass in this streaming parameter here. If for something that's going to be long like this, you might want to get the first little bit of it before the last part of it. Otherwise, it just waits for everything to be done. And so you just have to iterate through the response a little differently. Here we go. It's giving us a lot of information here. Yep. So the one problem that you might have with streaming responses sometimes is that like these little things where the where the text ends up on different lines, you can actually kind of combat that by putting in, if you put print, I think it's like end or something like that, end equals nothing. So then it doesn't add a new line in between that. So there we go. It's a pretty in-depth description of it here. Nice. And so here's an example with some video as well. It works basically the same way. Let's actually see how quickly this works.
島田彩花です。東京でほとんど全く違うと思います。
Yeah, it's another ad. It's like an ad or something for the Pixel. So we can have it give us a description of the video, include anything important which people say in the video. Something I've also seen that's a pretty common use case for this is what we call like the needle in the haystack problem. You can pass this a very long video or something, and you can say, okay, at what point does such and such thing happen? And it's actually pretty good at determining that. Okay, nice. Video is about a young woman named Seiko Shimada, who is a photographer in Tokyo. She's using the Pixel phone to capture the night city. And then it says some of the different things that are set in there. Very nice. Okay, and here's an example of using Gemini 1.5 for document analysis. So we're going to pass in this paper from Archive, which is specifically talking about how the million token context window worked in there. We have this uploaded to cloud storage, and we just say, okay, you're a document summarization specialist, summarize the given document. And then we're just passing all that data in here. We pass in the PDF file and the prompt that we have here, and we'll see what it gives us. Yes, these are all live responses, as you can tell, so who knows what they're going to say. Yeah, I think this paper is 77 pages, so it's a pretty long one. There we go. It took about 24 seconds to run there. Gemini 1.5 Pro is a sparse mixture of expert transformer model that builds on scaling mixture of experts, vision and language models at Google, blah, 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 blah. There we go. It gives us like a nice, good summary of that. And then we can also do the same kind of stuff for images. So for example here, oops, this is an image in here. So we can also say like, answer the following questions based on that. Actually, it says based on the PDF document. That's not correct. There's no PDF document in there. This one's just the image, but we can have it see about understanding the actual information that's in this. I believe that this graph is actually from that paper somewhere in there. I might need to update this notebook to make sure that that's fixed in there. Oh no, here we go. It does pass in the PDF file. I just missed that. Nice. So answer the question based on the PDF document and the image file. Look through the image and the PDF document carefully and answer the question. So it's able to take in both that PDF and the image and answer a question based on both of them. In this case, it also gives a citation of the and page number for the PDF document. Let's see what it will do. It says here it's able to identify it, but we'll see if it actually does. There we go. Oh, this is actually interesting here. It says there is a similar graph on page 5 of the PDF, but it is not exactly the same. It has a different title and different axis labels. That's actually kind of fascinating here. So we might have to, update this sample a little bit to see how accurate this thing is. Because we can actually open up this document here and see where that is. Yes, I know that it's sending me there. So our information says that it should be on page 10, which it is. There we go. This is that graph that we saw earlier. Scroll up. Yeah, that's interesting. It picked out this graph and said this is similar, but not exactly the same. Huh. Might have to adjust this prompt a little bit to understand why that's not working. But anyways, we have it going in there. Because the thing that is very interesting about these models is that, there's so much kind of variability in this. Like I could honestly run this 100 times and probably get slightly different responses every time. So this is the kind of thing where I would need to adjust things like the temperature or maybe top P, top K, or even sometimes adjusting the order these are sent in can also make a difference with this. So for example here, it actually says like, answer the following questions based on the context. In this one, it actually passes in the PDF and the image. The way it originally passed it in was the PDF and image first, but the way the prompt is structured, it actually says context last. So if I switch this around, it might actually make a difference. I'm actually kind of curious now. We're experimenting live. Isn't this fun? Yeah, while we're waiting on this, we can kind of look ahead at the next part of this, which is also, it allows you to put in multiple modalities at once using like videos, images, and text kind of all in one big prompt, which in this case it's using, look through each frame of the video carefully and answer the questions. Only base your answers strictly on what information is available in the video attached. So in this point, it's looking for, this is kind of that needle in a haystack problem I was talking about. What exact moment in the video is this particular image happening? What is the context of the moment? And what does the narrator say about it? Let's see what we have here. Huh. This is very fascinating here. Figure 1, Gemini 1.5 Pro equals negative log likelihood, cumulative average NLL for long documents, sequence position. There's a similar graph in the document on page 2. That's actually very fascinating. Huh. Is this, models are changing all the time. So We might have to see some of this stuff all the time. Fascinating. Anyways, I'll do a little experimentation and see what we can do about that. So anyways, let's look at this example here with video, audio, pictures all at once. So we have a nice 5-minute or so video. So we have an image here as well, which we'll see what the image is. I think it's a man with a dog. Yep, here we go. And I believe that it I don't remember where exactly it shows up in here, but I know there's the same guy. We might see him with his dog a little later in here. So let's pass them all in and see what it does. Do. Yeah, and this one, it makes a little sense. It's going to take a little longer because there's a lot of video to process in there. And if we looked at this, I'm trying to think, this would probably be in the this would probably be about 5 figures of tokens or so. Here we go. It took about 48, it was at 48 seconds. A man with a beard is taking a selfie with a dog. Narrator says the story is about a blind man and his girlfriend. Very sweet. There we go. 48 seconds. It might be using a different, it might be like starting at 0 or something like that, but this looks about like the same frame that's in there, 49. There we go. So that's an example of this tutorial. There's a lot of other ones in this repository that you can go in and try out to kind of get a sense of what's going on. So so getting started is where that one I just showed you was. There's also examples here showing how to use chat with this or the other kind of general introduction models as well. Grounding, prompt design. There's a nice one in here that shows how to write prompts in a good way for Gemini. And you can also see all sorts of different examples here from that. There's also some use cases here for like document processing, for education, healthcare, marketing. There's examples here for RAG if you want to do that kind of stuff. There's also examples in here for the embeddings API, which is just generating embeddings for these using Google's models. And there's also some for Vertex AI search, which is one of the ways that we can do grounding on custom data. Okay, so I'm going to open up for Q&A. Please, before you do sign off, go ahead and scan this code and take this quick little survey. I actually think it's only one question on here. It would be, it's great to help us, learn what everyone out there wants to know about the AI space. And so I see there's lots of information here, or lots of questions going on here. So let's take a look here about what we're going on. Gosh, there's lots of different. Let me scroll up in the comments so I can actually see where all the questions are. Join us Q&A, enter in the chat here, blah, blah, blah. This is recorded. Yes, enjoy the session today. Link, please. So I will send out these slides, I think, in the Slack channel. Can I upload? Ooh, I can upload files here. I'm going to upload this PDF of these slides right here. So you should be able to access that. So let's scroll up here. So one of the questions in here was, how can we use LangChain with Gemini? Okay, there's a few different things you can do on LangChain with Gemini. So there are, there are like integrations for Gemini in LangChain. So let me actually open up a tab here. Gemini LangChain. Here we go. So you can either use the Vertex AI one or the Google AI one. There's just 2 different APIs for accessing the same model because that's obviously a very smart thing to do. Sarcasm. So here we go. Google Cloud Vertex AI. There's like the chat model for this, and there's also the like regular language model as well. So you can use it just like any other model in here. If you go to Google Cloud Vertex AI, you can just pass in the model name, and it'll connect in just like any other model in LangChain. So this example right here is how you do that. So let me I'll send this link in just so you can have it. So this is the LangChain, the Vertex AI connected with LangChain. There is also a specific product or a specific feature that we're kind of calling LangChain on Vertex AI, which is known as reasoning engine for most actual technical folks. So reasoning engine, let me look for that, Vertex AI reasoning engine. Here we go, the reasoning engine API. As you can see in this documentation, it calls it LangChain on Vertex AI. It's basically just a way of deploying LangChain chains on Vertex AI, but it actually is pretty powerful overall. This is what I was referring to, where you can just pass in like a Python function into Gemini, and it will actually take whatever prompt you put in, extract the it'll figure out how to extract the parameters that it needs, and then actually make a call to that function, get the response, and then send that out to whatever user is doing. So this one's a very cool feature. There's notebooks in the repository that show how to use that as well. Okay, that's the thing on reasoning engine. Someone already sent in the console link. Thank you very much for doing that. Okay, what advantages does Vertex and Gemini have over VS Code and Copilot? Let's see here. There's a few different kinds of things with this. So are you specific? It looks like you're specifically talking about the kind of integrations side of things, or like the code completion side of things. So you can actually use Gemini Code Assist inside of VS Code. There's an extension for it. I would say overall what you can do is just try it out and see how it works for your use cases. I would say the biggest advantage is that it's much more tailored for Google Cloud workloads. So if you are already using Google Cloud for something, then it will, it knows a lot more about it than third-party services do. So let me actually Google that here. Google Code Assist, Gemini Code Assist, and AI Coding Assistant. So this is the actual information on it. It's also free to try, it looks like. That's kind of cool. So, and it has integrations with VS Code, all the other IDEs and stuff out there as well. So this is an example of that. And I'll share this link as well, so you can actually try it out. There is my Zoom link. There we go. Let's go back. Sorry, it's hard to scroll through all of these here. There's a lot of like people leaving and joining and stuff. Can I share the link? Can someone share the link to the repository or the Colab notebook? Sorry, I think I did close out my screen pretty quickly. So I will share that again. If you go to GitHub and search for like Google Cloud Platform Generative AI, that's what you'll get. And let me actually find the short link that I had for this as well. Go back a few slides. Here we go. No, come back. I'm gonna copy that link address and then share it in here. It's the link to the GitHub repository. Can I explain a little more about temperature, possibly changing resources, how it works, make it more creative versus accurate? So I will say I don't really know how a lot of this stuff works, how those kinds of parameters work, in all honesty. I focus much more on like the application side of like, okay, we have this model, now what can we do with it? So I can actually I can find some stuff for that, because it is something that I would like to understand more how it actually works. But in all honesty, I've been kind of overwhelmed just like everybody else out there. So, there's a certain point where it's kind of like I'll just, accept it and move on. Probably not the best way of going about it, but it's what I'm doing to make it through at this point. So that's it. That's something that I'll need to actually see. Let me do a quick little Google search here. Gemini temperature. Controls the randomness of the output. So it just basically controls the randomness. Let's actually see if there's anything that says what it is. I might even be able to ask Gemini, the web app, and see what it says. How it works in the generation process. This is much better than anything I would say here, but this makes a little bit of sense. View solution in original post. This sounds good here. If you have access to this site, then let's see if that works. Okay. Share this notebook as well as the slides. Yes, I will. LOL, trained on podcast will yield sounding like a podcast. Yes. Interesting. Do not make up any information to prevent hallucination. How do you prepare this compared to GPT 4.0 or GPT 4.0? I don't have information about the actual like comparisons of like the hallucination side of things compared to others. Why does it keep? I don't like the Zoom chat. It keeps moving around. That is kind of one way on this sort of thing, but the more kind of robust way of preventing hallucination is by using things like grounding, which I talked a little bit about earlier. I can actually show you the docs specifically for that, so you can kind of learn more about what those go in there. But if you want it to actually you can either provide information specifically in the context, or like whenever you provide your prompt, or you can use things like grounding to force it to force the model to answer based on information in a particular corpus of data. We are getting kind of low on time here, so Vertex AI grounding. Let me just open that up here. There it is. Oh, and actually, there's this guy talking about it right here in this YouTube video. I don't know who that is, but he looks like he might know what he's talking about. Oops, sorry, you didn't see my tab. Here we go, Vertex AI grounding overview, and then this guy right here. Yeah, you can go in there and check that out. Copy link address, and I'll share that in here. Okie doke. Oops, I don't want to send a direct message. I want to send it to the meeting group chat. There we go. So what is this? Oh, people have already sent that out here. Can you use your own model in Vertex AI instead of Gemini? Yes, you absolutely can. So there's a whole platform in place for creating your own models on there. Let's see here. Custom models. There's like custom training, custom model deployment. You can deploy and use your own models on there as much as you want. So here we go. This is the information on that. Train and use your own models. And I think that if you, let's see, if you already have like a pre-trained one, you should be able to deploy it actually. It's similar to what you would do with like Model Garden or with any of the Model Garden models or anything, because you can deploy anything that's on Hugging Face, for example, on Vertex AI. But here's kind of how you would do with the custom training side of things. Meeting group chat. What else we have here? Use our own model. Video processing might be expensive. How do you know how many tokens and how much is the cost consumed to process? So I showed a little bit of this earlier, but there is a method that you can use for the model to count the number of tokens. Here we go. If you do model.count tokens and pass in the context, I think that is completely free to use, but it tells you the number of tokens that are actually in that input. In this case, it was just a text one, so it wasn't very big. But it shows you all of that in there. And then you can just Google like Vertex AI Gemini pricing, and you can see how much it costs. In my job, I kind of wish that all this stuff was free. It makes it a lot easier. Yeah, it's pretty cheap overall. It's like, if you're using it, it does get more expensive the more tokens you're using in the window. But yeah, this is the information on there. Cool. So what else do we have here? Can you set global prompt constraints for a given session time period? For example, only draw your analysis from what provided. That way, any per statement prompt would already have what's added to it. You can just create a variable and add that constraint, but curious of the way to set these global constraints if you want every single one of those prompts. So you can't set it for like the entire Gemini model. You could you can create like fine-tuned versions of Gemini that have those kinds of constraints built into it. Or what you can do, you can use that context caching feature that I mentioned earlier, or you can use like the system prompts. Let me see if there's an example on here of that. I don't think this one has an example, but there are some in this repository that show how to do that. Or even, let's just look this up here, Vertex AI system prompt. Okay, and I think we are out of time here. So I think there should be one in here that talks about system instructions. Yeah, that's what I wanted. Prompt design, let me just put this in here so you can see it. So that's what you can do for those kind of global prompt constraints. And context caching as well is another way to do that. Okay, I think that we have all of the links in there that I've tried to share. I don't see any more questions, I think, and we're right at time. So thank you all so much for being here. I hope you learned something. I hope I didn't bore you too much. I'm glad that you guys all came. Please fill out that survey, and I don't know if there's anything else that needs to be said on the AI camp side, but I'm very happy to have you all here.
Great, thank you.